need to have a flashcard. Flashcard should say, on one side, polynomial. On the other side, it should say polynomials and all their derivatives are continuous and differentiable. So I'll say it again. One side should just say polynomial. The other side should say polynomials and all their derivatives are continuous and differentiable. They are everyone's favorite kind of function because of that. They just don't have anything interesting happening.
Repeat that.
So on one side of the card it says polynomial. On the other side of the card it should say polynomials and all their derivatives are continuous and differentiable. Just waiting for people to get their cards written out. So as I'm reading the problem, when I read that, basically, okay, all of us are better visual learners than we are, reading text. I've yet to encounter a person who said, "Hey, show me how to do it by showing me like a video." No, don't show me the video. Just give me like some written instructions, right? And it's like, no, show me the video. It's easier. So remember this image. Polynomials do stuff like this. That's a polynomial. This is a polynomial. This is a polynomial, okay? Nice and easy. Hello. No worries. Wasn't ringtone. Okay. It says values of f prime are shown above, which the following must be true for the interval -2 to 6. So looking on this interval, I just start checking questions. It says the graph of f is concave up. Points if you can think how I think. What am I about to do right now? What am I about to do right now, Parker?
Are you gonna do the thing where you like compare like the f prime of x, like the points?
3 points. I'm thinking a little bit more specific. No worries. What am I about to do right now, David?
Check the slopes, the secant slopes between the 2 points. Can you go back to the problem?
You're good.
Like the 3 to 1 and then 1 to 4, the differences between that to see if they're growing or getting smaller.
That's a good thought. I actually wasn't thinking that, but I don't think that's a bad thought because it talked about concavity.
Yeah.
And we've talked about how if function is going to be, if f is going to be concave up, then the secant slopes of
Going
f
to get bigger and bigger.
must have an increasing pattern. Hands down for a second. I want everybody to get points on this one. So no offense to David, that's why I paid him 10. There's a flaw with that thought, though. Like, that won't work in this case. This is where you're just learning to really think. We do know that if f is concave up, the secant slopes of f must have an increasing pattern. So David's thought was, let's go find some secant slopes. That absolutely won't help in this case. Who knows why?
Oh, I see.
Hands, show me hands, come on. Why won't it help? Think with me. I don't want one person, I want lots of people thinking. There's a reason it won't help. You can see it, awesome. If you can't, no worries, just learn from it as we talk about it. Why won't that help? Let's go, Megan.
Because that's the derivative.
Yeah, this is the table of f prime. If I go find secant slopes, I'll be finding secant slopes of f prime. That's why it won't help in this case. How many knew it? 2 points, 3 for Megan. Sydney, please.
So can you just find there's 3 minus 1 is, or it's -2, I don't know.
Keep going.
It's to get from 3 to 1, you have to subtract 2, and then from 1 to 4 is add 3. That's finding when it's changing, increasing, decreasing.
3 points for Sydney. What she's saying, you're basically saying the same thing as David, which is okay, but it's not going to work in this case.
Oh, it worked. I got the right answer.
Sometimes we luck out.
Yeah.
Be glad we do. If this were f, I could go say from here to here, the y-coordinate drops 2. The x-coordinate goes up by 2, so that's a secant slope of 1. Okay, that's true if that were f. But I don't really care about the secant slopes of f prime right now. So that's, does that make sense, Sydney?
So,
Well,
Oh, hold on, keep
you
going,
don't-
Sydney.
You don't even look at like the x's. Like, I don't know how to explain it.
Are you just looking at the y values only?
Yeah.
So you went, this went down by 2, then we went up 3, up 3, and then down 2.
Yeah. And then it switches between like -2 and 0, and then 5 and 6. So then there's 2 points of inflection.
Oh, we'll get to your point in a minute. You're good, 3 points. You and I are just thinking on different paths, no worries.
Okay.
That part, yeah, stay with that for a minute, Sydney. I just wasn't thinking there. Let's back up. We got to get all together again. When I read the problem, I saw that we had a graph of f prime. And then I had a question about f. What am I going to do? I'm trying to say you should do what I do. I'm not being very subtle about it. Abby.
Go to Danica's chart.
Yeah, Danica's chart. You must pay homage to one of my favorites, if not my favorite student in 15 years. Copy that. Go back to here. Paste it. How many knew that? 3 points, 4 for Abby. So, f is concave up whenever f prime is increasing. So raise your hand if you know whether I know A is true or false. One hand. F is concave up as long as f prime is always increasing. So do I know the answer to A is whether A is true or false? Allison?
It's false because you can see that it's not always f prime is not always.
Thank you. Allison started out by using some foul language, but she repented quickly. Thank you. Allison said f prime, from here to here, f prime went down. That's not f prime increasing. Therefore, A must be false. Okay, how many knew that? 2 points, 3 for Allison. Question? Full. B is the correct answer, correct?
Yeah.
Yeah. And Sydney did explain that correctly. I was on a different wavelength, so I apologize. What Sydney noticed was these values of f prime definitely go down, then they go back up. So that change of f prime from decrease to increase would cause 1 point of inflection. But then Sydney notices f prime continues up, but then goes back down. That would be, f prime changing from increase to decrease. Because that occurred again, that would guarantee at least 2 points of inflection. Please.
And points of inflection are just when the graph is going from concave up to concave down, right?
We have to be a little more precise in how we say it, but yes. F has a point of inflection when F changes concavity. So what they're asking us to do is identify where does F change concavity, and we're supposed to figure that out by looking at where F prime changes increase to decrease. That's how we figured out BE. Does that make sense? 3 points. Please.
Could you explain why it wouldn't be C?
Say again.
Could you explain why it wouldn't be C?
Perfect. 3 points for Stephen. Stephen says, wait a minute, tricky question. Yeah, welcome to the AP test. F is increasing. Stephen says, wait a minute. F is increasing as long as the values of F prime are positive. Well, unless I suddenly had a brain major lapse, all those values of F prime are positive. So hands up, who knows why B is not necessarily true? B falls into the category of, this is a statement that can be true. Okay? It just doesn't have to be a must be true. Who knows why? Come on. Why is B a C, not a must be true? This is very common on the AP test. Make sure this makes sense. Well,
We can't see all of the points in the graph, so we don't know if it goes down or
F prime has selected values shown. There could be hundreds of values of F prime that actually are negative. They're just not in the table. Does that make sense? How many knew it? 3 points. 4 for Alex.
So if that's true, then why is B true? Because if there's more points we don't know, then how do we know that it doesn't go back down and have more points?
Awesome. So Alice's question is, wait a minute, I feel like I'm going in circles, right? Because she's like, well, if we don't see all the points of F prime, how do I know B's true? Well, let me ask you a couple of questions. Are you very comfortable? You notice I say that a lot? Like, it's all about how comfortable you are. It's not like it's like you really believe it. Are you comfortable that F prime starts out decreasing? For sure. Because I went from 3 to 1. Now, in between, F prime could have increased, but for sure, somewhere F prime must have decreased. You agree?
Yeah.
Okay. Are you comfortable that F prime then changes to an increase?
Yeah.
Good. It could have done decreasing as well, but at least changed to increase somewhere. So at least once, F prime changed from decrease to increase, which means at least once, F changed from concave down to concave up. Are you okay so far?
Yep.
We keep going. I notice right here, F prime goes back down.
So that works because it says at least instead
Nice.
of exactly.
Yeah, welcome to the AP test.
That's rude.
Yeah, gotta look close. Does that make sense? Did you say that's rude?
Okay. I wasn't
I gotta pay for that one. It is, but it is the reality of the test. Please, Ken.
So on E, how come that also wouldn't be true? Because isn't it relatively true just when it goes from increasing to decreasing?
Hold on. Okay,
Oh wait, never mind.
you good?
Yeah, sorry.
No worries. Look up. Please try to follow the example of many of your classmates. And a lot of you are doing this without raising your hand because I know you're following it. That's how you get good at AP Calculus, is you don't try to learn the problem. You do what Keone just did, and like what Alice did, you go, wait a minute. You know, I can sense you're trying to make sense of it. If you are trying to make sense of the problem, you will never tire me out. Like, if I can tell you're trying to make sense of it, I will just relentlessly help you. I do have a lot of obligations, so I often have to leave because of other obligations. But I will not give up on you if you care about making sense of it. I just won't. If you don't believe it, again, talk to your siblings. I promise you they will back me up. Please.
I just had a question about like full test results.
Oh, one second. Let me just finish this one. Perfect. Anybody else here? Go ahead. Let me start the video.
Okay,